Sharing my screen, but before I share, is this one open? Okay. So chapter 6 and 7 are very, very important. So in case you cannot see my screen or you cannot hear me, please call me directly on WhatsApp. No message because I don't monitor the message. So chapter 6 and 7, and it's about switching. So today, last time we did the OSI model, Open System Interconnected. OSI, it's people are logging in. So you should know OSI, no? OSI, networking, networking center. So the open system interconnection. So it's that organization that will design the OSI, OZ, ISO. Now this is for the OSI. Now the other guy is OZ, ISO, networking. Yes. So the ISO is the International Organization for Standardization. And we created the OSI. So be careful between ISO and OSI. So ISO, we are there to create some standards. It's a big organization to create some standard. And in this standard, we did create OSI that has 7 layers. So it acts as the OSI, it acts as universal language, allowing different hardware and software to communicate by breaking down data and into layers. So last time we did chapter 1, layer 1, and anything relating to the media, the cables, the wires. And for the cable, we had 2 families, UTP and STP. The most used is STP. And we have the straight through cable, the console cable, and also, so when you have your packet tracer here, so if you don't know, let's say I put 2 switches, one switch and another switch. Normally, the crossover cable is used to interconnect devices that are the same. You see, switch, then I can use a crossover cable. So you see here, the first one, even if you bring the mouse on it, the first one is automatic. It will help you to choose the correct cable automatically. Here, if you know what you want to do, you choose yourself. Here, you can see the name down here, console cable. You see here's a straight line. So it's a straight through cable, the normal network cables. Here, you can see with some dots, it's crossover cable. The crossover cable normally is used to interconnect devices that are the same. So even if I don't use it and I take the automatic to help me, you see automatically I can see it's a crossover cable with some dots. But if I connect a switch to a PC, because we are not the same, normally it's a straight cable. If I don't use the correct cable and I use automatic, it will show me that it's a straight through cable. So network cables, we have straight through cables, crossover cables, and console cable. Console cable, as you know, is a temporary cable. We connect the PC to the switch console cable to do some basic configs, then we remove it. Anything else that stays is crossover cable or the straight cable. Let's say I want to and if you want to interconnect two routers in a lab, uh, you're in class and you want to do some demo, and you can use these two. You can take the automatic and you check. You see, because you are similar, you have the same, it's a crossover cable. But normally, routers, to interconnect two routers, we use a console, a serial cable. So all these information are important for a network engineer. So if you work in a lab, you can use these. Like next time that we'll be meeting at Captain Science Center, we're going to interconnect two routers and do some stuff. But in real life, if we interconnect two routers, we need another type of cable called the serial cable. So if I could automatic, you see here, these two red ones, you pick one, the serial cable. So for two routers, two distinct routers to get connected, we use a serial cable. So a serial cable is a specific cable to interconnect two routers. 19, I'll send it to you shortly. What's a serial cable is for routers? Okay, I give you. So a serial cable is used to interconnect routers. So how it works, if I take one cable, if I take a serial cable, I need a serial port. I don't have serial port, I have gig Ethernet. If you see Ethernet, it's the normal network cable. Fast Ethernet and gig Ethernet. Gig Ethernet is more faster than fast Ethernet. Network port. We can get fast Ethernet. Fast. Okay, I put like that, Ethernet. We can get also giga Ethernet. So these two, it's for normal network cables. Fast Ethernet, gig Ethernet. The only thing is gig or giga Ethernet is faster, and it's the most used nowadays. It's the most used nowadays. So I'm going to add this one here. 20. What is the difference between a fast Ethernet cable port and giga Ethernet? It's about the speed. So we use it for normal Ethernet cable. Normal network cable, sorry. So now we have another type of port. We have the console port, like you know, console port. And we have also the serial port for routers only. So the serial port is for routers only. Let me see. So as a network engineer, you should know all this. So I'm going to show you a picture of a router. Okay, normally we're not supposed to do router, but because I started, so I'm going to give you all this information. Very important, guys. Cisco router. I'm going to add port. Yeah, so if you take this one, okay, let's go to picture, image. Yeah, so we see here, for example, um, okay, I need something that is written. Let me see here. For the console port, you know, it's written console. So you can use network RG45 as a console port, or you can use that type B also. So yeah, you can be in. Anything is yellow is, let me find a good one for you. Routers. Router. Let me check here. I have one for the other class. I'm going to send it to you now. One sec, please. Let me check this one. To the other class. Where's comments? One sec, please. Yeah, because it's good to know your stuff instead of starting configuring, tapping. No, you must understand everything. I'm trying to find these pictures. And it was at the beginning, these two. Forward. I'm going to forward to yeah, okay, so you can please check your WhatsApp. If you check your WhatsApp, I did send you two pictures, and you'll see in yellow, with yellow sticker, it's for gig Ethernet port. For console port, it's written. On top there, you'll see aux. Okay, let me send to myself also via. My WhatsApp is that side. Let me check. How can I send to myself? Okay, anyway, please check in your WhatsApp. I did send you some port where you can review them. You can view fast Ethernet, gig, console. When it comes to serial port, I'm going to show you here. Router serial port. Serial. And it's something we might do next time. What is it? Let me go to pictures, image, yeah, it's image, yes. So you see here, if you have a router, sometimes you'll have some blank and some empty spaces. So you can remove them, you remove and you buy a slot, a module or interface, and you plug them inside. You plug them inside. So it's what I'm going to do here. I have a router. I click on it. I zoom in, and you can see that I have two black walls here. It means I can buy a card and insert inside. So on my left side, I see some card. If I click on one, I can see the picture down here. If I click on another card, I can see here is the cover. I can use to cover it. But before you cover, you need to power off. Then you can cover it, you see. It's covered. So you can unscrew, you can remove it. Then you put a serial cable. This is a kind of serial cable. So I need to remove them first. I remove the cover. I remove the cover. I go to a normal. You see, this is a module for serial ports. So serial ports are not there. You must buy and put and install. You see, I did install. I power on now. I go to CLI. My system is loading to take them. So if I ask you a question, what is the command to use to view all the ports on a router or on a switch? Who can tell us? The command. So if we ask for some questions for a router, you tap no. If not, we're going to ask you 1,000 questions. So what is the command you tap to view all the ports that are available on your router or on your switch? Who knows the command? No one knows. Sorry?
It will show interface brief.
You're almost there.
So IP interface brief. Sorry.
Very good. Show IP interface brief. So this command is the command you type to view all the ports available on your. So you see now I have serial ports. If I go to the other router, didn't install any port. You see here it's blank. It's blank or dark. If I type here, I put no, and I tap enable show IP interface brief. You see here, I only have gig Ethernet port, but I don't have serial. So if you want to view a serial port, like we did for the router here, you need to install the serial card. If you install the serial card, you see this guy, you must buy. Then you remove the cover, you install, you insert. So I go here, open it. You see, I take the first module and I take the picture down here. Here it is. We say cannot add because it's on. I must power off first. Then I add. Okay, you can add one or two. Then you power on again. You see. Then you go back to your CLI. It's going to install the module. It's going to install. System. It's loading the Windows 11 for the router. Remember, the name of the operating system is what? Is the iOS. iOS. Remember the question for last time? What is iOS? Internet Working Operating System. It's the operating system for the router and the switch, like with Windows 11 or Windows 10 for a switch or a router. ISO, organization of standardization, something. And we created the OSI, Open System Interconnecting, with 7 layers. So all this stuff, you cannot say I'm a network engineer and you don't know these things. So it's very, very important to. Okay, now that I did install both, let me check if I can install. See, I take a serial cable. Now I have serial port. You see, serial port. You see now. So to interconnect two routers, normally it's a serial cable. Okay, so I don't know why I started with the router. Now let's go to our switch. Let's go to our switch. This is a switch. What can we know about a switch? So a switch is a layer 2 device. Switch. It's a layer 2 device. Layer 2 means what? The data link layer in the OSI model. We have 12 port switch. We have 24 port switch. And we have 48 port switch. So according to the type of switch that we have, Cisco switches. So it depends on, so this one, for example, the 1, 2, 3, 4, okay, this one is not a Cisco. Here, we have 6 plus 6, 12, 12 plus 12, this one is 24 port. 24 port, this one is 48 port. So if you want to interconnect 40, a lot of PCs, like 48 PCs or 40 PCs, and you use the correct one. You see, this one has 48 port. So 6, each row is a 6 plus 6 on top is 12. A block of 12, 12, 12, 12 is 48 port. Or you can have only half, 24 port or 12 port. Now, we also have something called, I'm bringing you guys my experience in networking. Yeah? So this one, please take them seriously. We have something called managed, and something called unmanaged. Yeah, we have managed switch and unmanaged. Managed is the guy who is like your cell phone. You buy a cell phone, you can do some settings, changing the colors, add names, install drivers, install some apps. You see, you can manipulate, you can do some settings. It's managed. The unmanaged, it's like a toy. You plug it, you connect your PCs. It does. You can no configuration. You cannot do anything. So very important. Job interview. What's the difference between managed and unmanaged? If you don't know, you know your friend. Difference between managed, and unmanaged switch. You do some research, you document them. See, manage, you see, you can do a lot of things. You can do some configuration, security, and a lot of stuff. The other one, you cannot do such thing. It's just plug and play, yeah, something like that. So if you go to Cisco website, you also get some. So very important. Let's go to my questions here, chapter 6 and 7. SI, we know it now. Why it's important, we know it, to classify IT stuff in layers. How many layers? We have 7, you know them. A switch, you know. Managed and unmanaged. What we different, you know now. How many ports? You know now. Now, something very important. We switch and extend MAC addresses. What is a MAC address? You see, any PCs to go to internet need 2 addresses. I think we did that many times. The PC need 2 addresses. The first one is what? Physical address. Physical address. Or MAC address. You can see. Never change. We can never change it. And we have another type of address we call it logical address. Logical address. Or IP address. Managed by the router. We can change IP addresses like you can change your cell phone number. The first one here. I'm here. Managed by the switch. So very, very important. You cannot say you're a network engineer, you don't know what is the difference between a physical address and logical address. So when you, the PC, you want to send a data to go to internet, we have 2 parts. The first part, the physical address, will be managed by the switch. The switch understands MAC address. And inside you have source MAC address and destination MAC address. Where do you come from? Where do you want to go? Then it will send your data to a router. When it reaches the router understands only logical address or IP address. Source IP, destination IP. I think we did that, no? Last class, I think we did, yeah. So you're here when you want to send data or receive data, we have 2 parts. Layer 2 for the switch, we have source, destination. Layer 3, that will be managed by the router, source IP address, destination. So when you send, where do you come from? Where do you want to go? Then the switch will send to a router. The router will check layer 3 with IP address. Where do you come from? Where do you want to go? Then we can send. So it's very important. That's why we have the switch and the router. If we ask you, if you have your PC, how to view the 2 addresses, you type CMD, Charlie Mike Delta, you should know now. And you type what? IP config space /o. This is the command to view some settings or some features, some information from your network card. You press enter. Then you'll see a lot of adapters. Window configuration, Ethernet adapter. If you see Ethernet, it means what? Your network cable or your network, yeah. So I'm not using network cable. I'm using Wi-Fi. So I go to Wi-Fi. You see here Wi-Fi. Wireless LAN adapter. So then you check information here. You can see here physical address is your MAC address. So we switch and extend this one, and it is what we're going to do. Then we have the IP address. So IP address Remember chapter 11 that we did before, we have IPv4 and IPv6. So here my service provider is giving me IPv6 address. It can be IPv4 or IPv6. So this one is called the logical address. So the switch will check this one, and the router will check this one. So you see IPv4 is here, for also. So it depends on the configuration of my ISP. So these are the two addresses. So the switch will focus on the MAC address. The switch will focus on the physical address or MAC address. So when you have your switch, MAC address, the switch will focus on the MAC address. If you have questions, anytime, please unmute yourself, tell us your name, then feel free to ask your question. See me, I like doing some research all the time. I complain. You see, unmanaged switch are just plug and play, no settings, no configurations. So you can read that, very important. You see, managed. Okay. So that's the difference between these two. Now, what a MAC address is, so each PC has a MAC address. Each PC has a MAC address. If I have a PC here, and I open it, and I go to config, I'll see where's the MAC address, not config, desktop, IP config. No, it's not here. No, it should be in physical. Physical, zoom in. I go to settings, fast Ethernet. Yeah, if I go to the fast Ethernet interface, fast Ethernet, it means my network interface card. I can see my MAC address here. So any PC should have a MAC address and an IP address to communicate. Now, the switch is what? The switch is going to record anyone, and we know that the switch is there to connect PCs in one place. If I had another PC, so we use the switch to connect a lot of PCs in one place. Now, what happens when you connect your PC to a port? The switch is going to record the port and your MAC address that is there. If I tap enable, show, this is the new command for you guys, MAC address. Show question mark. You see MAC address table. So all the MAC addresses will be stored in a table. So show MAC show all the MAC addresses are recorded in a table in the switch. So inside the switch, we have a table. It's called the MAC address table. If I press enter, this is the table. I have a VLAN. We'll do that in CCNA2. MAC addresses, for now I have nothing, type, and port. Let me generate some traffic. Here, I'm going to give an IP address, for example, 192.168.10.2. Oh, well, nothing. Yeah, 192.168.10.2. I keep it like that. I close it. The other one, desktop, I put here 192.168.10. We generate traffic. I'm going to ping. Ping is a tool connectivity. But 10.2. So ping is like you are dialing a cell phone number. If it rings and someone picks up and say hello, hello, you see, I have 0% loss. It means we can communicate. So here I'm testing the other PC. I can test myself. So I say hello, hello, it rings and you pick up. Then let's go to the switch and check again if it is a MAC address table. You see now, I have a table. You can see on port 1, the MAC address of the PC that is connected on port 1 is here. On port 2, the MAC address of the PC that is connected on port 2 is here. So that is one of the features of a switch, to record per port the MAC address of a PC that is connected to that port. You see? So you see, question number 8, what a MAC address is. A MAC address table. A MAC address table is a table in a switch that will record per port the MAC address of a device that is connected to that port. What command you use to view the MAC address table? Show MAC address table. And at the layer 2, the PDU is normally a frame, but normally we use the MAC address. So we switch understand the MAC address. Now, okay, today we're going to do half, and on Tuesday we continue doing the other half. What are the two forwarding methods processed by the switch? So I'm going to show you, and then I'm going to explain to you. It's chapter 7, this one. I'll show you, you read, then you explain. So we have videos. So I try to make it simple for you. Yeah. So these are the two forwarding methods. What does it mean? When a PC sends data, the switch will receive it. Then the switch will going to check your data. If the switch is going to check from A to Z or A to Z, if everything is okay, before I forward, we call it stored and forward switching. Cut through is another method of processing your data. When the switch receive your data, it's going to check, where do you want to go? I want to go to China. Okay, go. It doesn't check if everything's fine or not. So these are the two methods of processing a frame or a MAC address here. So it's very, very important. You can read this one. Then we continue. Okay, we're going to continue shortly. Okay, so this is also very important to know from this switch. So we are combining chapter 6 and 7 because it's the same. So today we do have, and on Tuesday, we're going to continue and finish. So for this, you can study chapter, you can even read both, chapter 6 and 7, but we're going to finish them. Don't forget to do your chapter exam. After chapter 1, 2, 3, you have an exam. Please don't forget to do that. So the answer to this question, what are the two forwarding methods? Is store and forward, and we have through. And then, yeah. Okay, for now, let us, what a serial cable? A serial cable is to interconnect two routers. This one also you know. So anything else, we'll be doing a bit later. Let me check quickly chapter 6 for you. So remember why we are doing this chapter. The OZ layer, we did last time, the physical layer, chapter 4, anything related to media. Now we're doing the data link, anything related to the frame, MAC addresses, and the switch technology. We'll chapter 6 and 7. Then after that, we go to chapter 8. We'll be doing the router, what a router is, what is packet, what is IP address. See? When we know all this stuff, then we can do good configurations. So we're going to study each of them. So we go step by step. That's why we are doing this one. Data link, let me check what is in. I'll tell you what is the most important. Anything else? I did explain to you when you send data, we have two addresses. Physical address layer 2 that will be understood by switch, source MAC address destination. Layer 3 will be managed by the router. IP addresses, IPv4. If one is missing, no communication. All these two should be there, and so the source destination should be there. Okay, anything else here is only some readings, some data link layer standard. Again, these guys will decide how it will organize, how traffic will flow, and all this stuff. Topology, physical topology is physically how you're going to organize your stuff. Logical is how the data will flow. It's like your human body. When you touch your arm, your legs, your tummy, it's physical. Now your blood that is circulating and that's moving inside our body is called logical topology. So logical is the flow of data and IP addresses in my network. Okay, all this stuff in the old days, how we set up, we don't do that anymore. Nowadays, it's star topology. Everything is connected to a switch to a router. But in the old days, we had this kind of full duplex and half duplex. You see, for now, I'm talking to you only. You wait, you listen. It's half duplex. If I'm done, then you can talk to me. So half duplex is one-way communication. Full duplex, we can talk together. I'm talking to you, you can talk to me, you reply, we talk, you sing together. So as an IT engineer, you should know the difference between half duplex and full duplex. Very important, you can check this slide. Okay, so it's very, very important, and I think I did ask you the questions. Mm. What's the difference between half duplex and full duplex? You see, so you should know now. Okay, all these I'll explain a bit later. In the old days, for half the system to manage the half duplex with one way, the system is called CSMCD. It's like traffic light. It is a traffic light. If it's red, you stop. If it's green, you go. So for in the old days, for half duplex to manage the half duplex, this one was the technology that was set up. If the line is occupied, you're going to tell anyone else, guys, don't send anything, the line is busy. When the line is free, hi guys, the line is free. So it was a technology to avoid collision, accident. So for we have CD for network cables and CA for wireless. In the old days, have to avoid accident. But nowadays, everything is full duplex, so we don't need this one anymore. The frame is the envelope we see at the layer 2. So this is your data coming from the top down, the OSI. When it reaches layer 2, it's going to add other info, like MAC addresses. So what is very important to frame here, what's very important is, this one is finished. What is important to the frame is the size of your frame. I'll show you. Yeah, so this is an example of frame. So the envelope that you find at the layer 2 is called the frame. This is it. And inside, we have source MAC address and destination MAC address. So that envelope has a size. You can read this one. It should be between 64 bytes and the maximum 15 and 18 size. See, when you want to go doing unboxing, we check your weight. You must fall in that category. If you're too heavy, we say no, you must lose some weight. So for a frame to be a good frame, the size should be between 64 bytes, and if it's less, we call it a rant frame. The, the switch will not process it. The switch will say, okay, maybe that frame was broken somewhere, so it's not complete. I'm not going to process it. If it's bigger than 15, 18, you say, no, it's too big. I cannot handle it. We call it jumbo frame, and it will be discarded. So this slide is also important. I give you 1 minute to read it. And we are done for today. We'll continue on Tuesday.
Thank you, Mr. Mark.
Okay, so if you check in the question again that I'm going to post in your group, what is the normal size of a frame? What is the frame name? What is the frame name? That size. So if that size is less than 64, what's the name of the frame? If the size is less than 64, you know. What is the frame if the size is bigger than, and anything else we'll be doing on Tuesday. Yeah, so please go through chapter 6 and 7. If you don't understand something, write it down. When we meet next session on Tuesday, feel free to ask your question. Send it to me before the class. I prepare it for you. Okay, so that's all for today. We're not going to, okay, MAC addresses. We're going to explain more next time. We're going to explain more and all this stuff. Any questions? So if no questions, then that's all for today. I'll send you the recording tomorrow. So I wish you a good evening, good weekend, study, and yeah, see you next Tuesday.
Thank you.